So my advice on number 2 is to go ahead and actually find y first. So find y first, then go and find x. I'll give you 45 seconds to try him. Deal. So to solve for y, remember, we're going to assume that this is tangent, so we know we have a right angle right there. So that means we can use the Pythagorean theorem. Which one is going to be picture? Yeah, y, good. So then we're going to add up those other sides. 9 squared plus 12 squared, my 2 legs. And when we put 9 squared plus 12 squared into our calculator, I'm going to get 225. How do we get y by itself and get rid of that squared? Yeah, we'll take the square root of both sides. So now we know that y is equal to 15. But here's the thing. We just figured out that this stretch is 15, right? That little squiggle that I just drew in, this little part right here, what is he equal to? Not quite. 9, yeah. Because remember, the radius is the same all the way around the circle, right? So if this piece right here is 9, that means that this piece is also 9. So then is left for x if that whole thing is 15 and that other piece is 9? 6, beautiful. So x equals 6. All right, looking at number 3, we want to decide if this is tangent or not. You're going to use the Pythagorean theorem. I will give you 45 seconds to try this guy. Okay, so to decide whether AB is tangent or not, we want to know, does it make a right triangle? So decide if it's a right triangle or not, we're going to put it into the Pythagorean theorem. Only works for right triangles. So if our equation is true, that means that it's tangent. Number 1 was 24. So in number 3, which one's going to be C here? Yeah, C is going to be 26 because it's the longest side, or it's the side across from what could be the right angle. And we'll use those other two guys, 10 squared plus 24 squared. So if we put 10 squared plus 24 squared into our calculator, we're going to get 676. And if we put 26 squared into our calculator, we're going to get 676. So since those two are actually equal to each other, is that tangent or not tangent? Yes, it's tangent. If that equation came out as false, then it would not be tangent. All right. Go ahead and start taking a look at number. I'll leave 1 through 3 open there for you. 1 through 4. Or try number 4 is what I meant. All right. So it's telling me that AB is, 8. That AE is 20. That CE is 18. We're trying to figure out what BC is. So we're actually going to start with AB, this 8. What will AB be equal to? What will AB be equal to? AF. Very good. So we know this piece is 8 as well. So that means how long is FE? If that whole thing is 20 and AF is 8, how much is left for FE? At 12. So then what else is equal to 12? What else is equal to 12? DE, very good. So this bit over here is also. So that means how much is left here for CD? Six, good. We're going to take 18 minus 12 to figure out that this bit is going to be 6. In that case, what's BC equal to? Beautiful, 6. It's going to be over here. Okay, go ahead and try number 5. Those things are congruent, so we're going to set them equal to each other. two tangents intersect outside of a circle. That means that these pieces of our tangent are going to be congruent. Congruent means equal. So we'll set 4x minus 8 equal to 2x plus 8. So what I'll do first is subtract 2x from both sides. So we have 2x minus 8 equals 8. What do I do with that minus 8 to bring him over to the other side? Add it. Good. So that means that 2x equals 16. So when we divide by 2, what's x equal to? 8. Good. All right. So the name of the game on 6 and 7, stuff's equal. Stuff is equal. So go ahead and try 6 and 7. Okay, so this one tells us that, oopsies, px is congruent to py, and that AB is 12. And we want to know how long CD is. So generally, stuff is congruent. So what will CD be equal to? Does it kind of match up with? Yeah, so AB matches up with CD. So since AB is 12, CD is going to be 12. Okay, so for the next one, remember, since those chords are congruent, those arcs are going to be congruent. And stuff that's congruent, we set equal. So set those two things equal to each other and solve. I'll give you a little bit to try that one. Good deal. So on number 7, since these chords right here are congruent to each other, that means that the arcs that they cut are congruent to each other. So I'll set 7x minus 23 equal to minus 3. What should we do first to solve? Yeah, let's subtract that 3x from both sides. So then we have 4x minus 23 equals negative 3. Make sure to bring the sign down with it. What should we do with that 23? Yeah, we're going to add 23 to both sides. So negative 3 plus 23 is 20. So when we divide by 4, what is x equal to? 5. Beautiful. Right. I would love for you to go through and find all of the arcs in that circle for 8 through 10. I'll give you about 45 seconds to figure out all those arcs in that circle on 8 through 10. Okay, good deal. So in this guy, it says that TU is a diameter. So that means that everything on this side of my circle is going to have to add up to 360. Or I'm sorry, 180. Half of a circle is 180. Half of a circle is 180. So I know this arc is 90 and this arc is 55. If these are all going to add to 180, how much is left for SF? Yeah, good, 35. Okay. Now, to find from E to T, you could also use that as a diameter. So we know all of these angles, all those arcs are going to add up to 180. Or we could say that these are vertical angles, so they're congruent. And this is also 55. TU is a diameter. So that means from T to U is 180. So to find EU, I'll take 180 minus 55. When I do that, I'll get 125. So the first one wants us to find EUF. So from E to U to F. Since EF is a diameter, what is the measure of arc EUF?
180.
Beautiful. Beautiful. 180. Okay. So now we're looking at SF. So the shortest distance from S to F. We figured out that would be how much? Yeah, 35. Good job. Then we want the measure of arc STF. So we're going to start at S, go in the direction of T, and then end up at F. So we're going to add together 90 plus 55 plus 125 plus 55. Or we can take that whole circle, 360, and subtract out what we don't have, that 35. We'll end up with 325 for that guy. Okay. So that, here's what I want to remind you on number 11. About quadrilaterals and circles. Opposite angles add to be 180. All right, so that's what we need to know for 11. Opposite angles of a quadrilateral inscribed in a circle, opposite angles are going to add up to 180. So go ahead and try number 11. All right, good deal. So opposite angles will add to 180. Remember, opposite means across from. So opposite 5x is 4x. So those will add together to equal 180. What is 5x plus 4x? Yeah, good, 9x equals 180. When we divide by 9 on both sides to solve for x, what is x equal to? Good, 20. I can do the same thing with my other set of opposite angles. Opposite angles, 71 and y, will add together to equal 180. What do I have to do to get y by itself? Good, subtract 71. So that means y is equal to 109. Okay. On this next one, our vertex is on the circle. So that means my angle is equal to my arc divided by 2. Go ahead and try number 12, please. Good deal. Okay. So, which one is my angle in number 12? The 30 or the x? Yeah, 30 is my angle. Good. So that makes x my arc. Since x is being divided by 2, to undo that division, I have to multiply by 2 on both sides. So these 2's divide away. So I'm just left with x. 2 times 30 is 60. So x equals 60. Okay. So now we're going to try number 13. Once again, our vertex is on the circle. So our angle is equal to our arc divided by 2. Go ahead and try number 13. Good deal. So on number 13, which one is our angle? X or 120 or 114? Yeah, X is our angle. Remember, angles are formed by straight lines. So that makes my arc, my curvy part, 114 divided by 2. And when we take 114 divided by 2, we get 57. All right. On number 14, notice that angle ABC cuts off this arc, and angle ADC cuts off the same arc. Go ahead and try number 14. Okay, so we're going to set these two things equal to each other. Since they both have the same arc, that means that these two angles must be the same. So we'll set 2x equal to 5x minus 81. Now, for some reason, these problems get kids all sorts of upset. So make sure that you get all of your variables to one side. So I'm going to move my 5x over to the other side. Minus 5x is negative 3x. Equals. Those add to 0. Notice I have a minus sign in front of 81, so that's negative 81 over there. Then when we divide both sides by negative 3, to get x by itself. A negative divided by a negative makes that positive 27. Good deal. So for number 15, things you need to know about a triangle. If you have a triangle inside of that semicircle, you're going to have a right angle right there. Also, the angles of a triangle add up to 180 degrees. So go ahead and try number 15. All right, good deal. So you can memorize the rule about a triangle in a semicircle, or I know that that part right there is a diameter. So that means that this arc right here is 180. So to find x, if we ignored everything else, you would take that 180 and divide it by 2 and get 90 right here. Let's zoom in a little bit more. 90 right here. So we know x is equal to 90. Now with the triangle, we know that all the angles of a triangle add up to be 180. So we have 90 plus 70 plus y equals 180. 90 plus 70 is 160. So what is y equal to? 20. Beautiful. All right, on number 16, since my vertex is inside of the circle, my angle is going to be equal to my intercepted arcs added together divided by 2. Go ahead and try number 16. Okay. So in this case, which one is my angle? Yeah, my angle is x. He cuts off this arc 124. And then we'll also take the arc from its vertical angle across the circle. So we'll take 124 plus 104. So that's 228. And then we'll divide by 2. So that's 114. Did you get the same thing? Good deal. Okay. So there's 8 through 16 if you need to take a quick screenshot. All right. Now we're looking at our angles. So when our angles are this guy, when we have outside of the circle, our angle is going to be equal to our outside arc minus our inside arc divided by 2. So go ahead and try number 17. You're going to be doing that angle is equal to the outside arc minus the inside arc divided by 2. Right, good deal. So in this picture on number 17, which one is my angle? X, good, equals. Which one is my outside arc? Good. Yeah, 170 outside arc. Then my inside arc, this guy in here, 63. So when you put 173 minus 63 divided by 2 in your calculator, what did we end up with? Yeah, 55. I got the same thing. So 173 minus 63 is 110 divided by 2 is 55. All right, on 18, you're going to use that same outside minus inside divided by 2. How much would the inside be here? Very good, 130. So we got that because the whole circle is 360, and we'll subtract out the part we already have, 230. Cool, so you're going to use this rule up here. Go ahead and solve for x. Okay. So my angle here is x. Our outside arc was 230 minus our inside arc was 130. divided by 2. So when we take 230 minus 130, that's 100. 100 divided by 2 gives me what for x? Beautiful, 50. Very good. Okay. Number 19. Remember, for segments, since we're inside the circle, part times part equals part times part. That's what we're doing for number 19. So I will give you a second to try this one. Okay, good deal. So over on this guy, I like to go ahead and start with x. I'm in the middle of something. Bring that conversation up to me a little bit later. So my outside part is x. What do I multiply x by? What do I multiply x by in 19? $16, good. And what do I multiply together on the other side? Good, 8 times 18. So we know that x times 16 is 16x. What's 8 times 18? $144, thank you. So then to get x by itself, we'll divide by 16 on both sides. Is that 9? Is it 9? Okay, nobody's answering me, so I'm just going to trust myself. If you put in 9 and it's wrong, sorry. Okay, on number 20. So since part of my segments are outside, that means we're going to have the outside part times whole equals the outside part times the whole. So go ahead and try number 20. Okay. So on this top piece, my outside part is 18, and the whole thing is also 18, equals. The outside part over here is 12 times. What's the whole thing here? Not 12x, be careful. So remember, if this were 5, we would add those together to get the whole thing to be 17, right? Beautiful. So we're going to add those together. So we'll have x plus 12. So then we'll multiply this. 18 times 18 is 324. We'll distribute that 12 on out. 12 times x is 12x. Beautiful. 12 times 12 is 144. Next, we'll subtract 144 from both sides, right? So we'll get 180 equals 12x. So then what is x equal to? 15, beautiful. Okay, that outside part times whole and outside part times whole, we're gonna keep using that for number 21. So this guy we're gonna keep using here. Okay, so on 21, we are still doing out times whole equals out times whole. Over here, my outside part is 8. What's the whole? Careful, what do we do with the x and the 8? We don't multiply them, we add them, right? So I want 8 plus x here. Equals. On the other side, my outside is 7. How long is that whole thing? Yeah, 7 plus 17 is 24. So now we'll start to solve this guy. We'll distribute our 8 through. 8 times 8 is 64, plus 8 times x is 8x equals, what's 7 times 24? 168, good deal. So then to get x by itself, we'll subtract 64 from both sides. So 8x equals 104. Beautiful, thank you. So when we divide by 8 on both sides, x equals 13. Okay. So for these next two, remember the equation of a circle is x minus h squared plus y minus k squared equals r squared, where your center is at h, okay? And your radius is r. So go ahead and try 22. Okay, so the big thing to remember about the equations of a circle is that whatever's on the inside of the parentheses, it's the opposite with what's in my center. So we have an x plus 2 here. That means what's the first part of my center? I have x plus 2, minus 2, good. It's the opposite. Now, nothing is being added to this y. So what's the other part of my center? 0, good. Good, good, good. Then to find the radius, we're gonna have to take the square root of what it's equal to. The square root of 25 over 49. When we take the square root of a fraction, we take the square root of the top and the square root of the bottom. The square root of 25 is 5. The square root of 49 is 7. So the radius is 5/7. Okay, we're going to be using that equation for the last problem. I'll go ahead and give you a little bit to try him. I'm not quite sure what you mean. So hopefully when I go through the problem, I can answer your question because I'm not 1000% sure what you mean. Okay, so first of all, we know that in these parentheses, it's going to be the opposite of the sign for my center. So since I have -2 in there for the x part of my center, I'm going to have x what squared? +2, good, because it's the opposite. Plus, now I have a -9 here. So I'm going to have what, I'm sorry, y what squared? +9, because it's the opposite. Then we're going to have to take our radius and square it. So we're going to have to take 3 and square it. What's 3 squared? 9. Good. So the way you're going to write that out in Canvas, you'll have x plus 2, close parentheses, caret 2 plus 5 plus 9, caret 2 for that squared equals 9. Now, actually typing it out in Canvas is a pain in the butt, and I'm very much looking forward to next year so I don't have to use Canvas for everything. But I wanted to let you know that on 11.8, the equations of circles homework, I'm going through and making sure that if there are any typos, you forgot the 2, you forgot your caret, something like that, I'm going through and making sure that I'm fixing those for you. So if they haven't yet, give me a second. I'll get in there and get those changed. I went through all of them at about, I want to say like 8:45 this morning, but I've been teaching since then. So, all right. So there is your review. I'm going to go ahead and turn off the recording. Good deal.